Welcome to an introduction to energy. I love this unit because it's one of the most conceptually easy for people to understand, and it has a really good analogy that we use the analogy is something we use every single day. The analogy for energy is money, and since we all know money, you all pretty much have an idea of how to handle energy as well. Alright. And this one, who hasn't shown her face yet in these videos, this is Boadicea or Boudica, and she really likes to be up, and I'm not going to let her climb. All right? Hi. Yes, you're purring because you're being held. Okay, let's go down. Thank you, Bodhi. Good job. Okay, so energy. It has this amazing analogy to money, and money is something you know how it works. You understand how money works, so you really understand how energy works already. It's a pretty clear analogy, and so that's one of the reasons I like it, is it takes people very little time to understand what's going on with energy. So to start with, let's talk about this analogy. And the analogy to money, let's just say you are looking at your bank account over the last month, and you want to make sure all the accounts match up and the numbers match up. So what you do is you take the starting amount of money, whatever you started with on the first of the month, and then you have things that change the money, and then you have, at the end of the month, your final amount of money. So that's, the basics of reckoning your bank account. Okay, so I'm not saying you actually do it, but that's, how it works. So starting money changes to money, final money. This is directly an analogy to energy. With energy, what we're going to do is have this conservation of energy equation. And what it's going to be is the initial energy plus or minus the things that change energy is equal to the final energy. See how similar those are? Ta-da! So with money, you might have certain types of money to start with. What kinds of money might you have? Well, there's always whatever cash you've got. And then you might have stuff in a savings account or a checking account. You might have like CDs or stocks or bonds. All these things are types of money. And then same thing for final. You could have different amounts or maybe the same amount of all these things. Now, what changes the amount of money you have in your bank account over a month? So stop for a minute and think about what would make changes to my bank account. So you might say bills. You might say paychecks. Gifts, I don't know. Birthday! The checks come in. So those three are just examples of things that change the amount of money that would be in your account. Now, these have direct, again, analogies to energy. So we're going to be talking about different types of energy, and cash is something that's easily used. It's easy to access, it's easy to transfer in and out, and that's going to be related to what we're going to call kinetic energy. Kinetic. Now, if you think about the word kinetic, we saw that before with kinetic friction. And kinetic friction is what type of friction? It happens when two things are moving. So this is movement energy. This is something where if an object is moving at all, it has some energy because it is moving. And that's kinetic energy, kinetic movement. These three are all kind of stored energy. And what we're going to call that is potential energy. So potential means, it's, in this case, we're going to call it stored. And it has the potential to do stuff. Okay, so it's not active like kinetic energy is, but it's potential. The potential is there. It's stored up waiting to do something. So we got the same thing here. We've got kinetic and we've got different types of potential. And then for now, I'm just going to talk about this change in energy stuff. I'm just going to call this by the term we're going to define it as. And we're going to call those things that change energy work. type of work that causes a paycheck, a different type of work. So we've got this analogy here, and we've got the movement, the easy to use stuff. We've got the stored energy, so the kinetic energy due to movement. We've got stored energy. What types of stored energy are we mostly going to be using? We're mostly going to be using two types of potential energy. One is the energy stored in a spring. So if you pull a spring apart, and just hold it there, there's potential energy stored in that spring. It wants to do something. As soon as you let go, it goes boop. So when a spring is compressed or extended, there is energy, potential energy stored in a spring. The other type of potential energy we're going to be talking about is potential energy due to gravity. And now what does that mean? Well, just like if you pull a spring apart and you let it go, it goes whoop. If you take something and lift it off the ground and let it go, it falls. So again, we have something that's got the potential. It's sitting here. So the marker's sitting here, and it's got potential due to gravity. So those are the two types of potential energy we're going to be using. And then we've got the kinetic energy. So let's do a couple examples, just real quick examples of how this would work. Okay, so the first example, we have a skier that starts at rest on a slope. So we start with no speed. It's very icy, okay? So very icy. And the skier ends at the bottom of the slope with some velocity. What type of energy conservation or energy conversion is happening here? So what's our initial energy? For energy, what we're going to want to do is we have to distinguish the initial part and the final part. This is different than what we've done in most of our other processes. Most of the time it's just been like, well, here's what we've got. This is what the forces are. We need now to go way back to kinematics and think about initial and final stuff again. So here I would say, well, I'm going to say my initial time is up there, and I'm going to choose my final time to be there. And then I can use this idea to figure out what's going on. So initial energy plus or minus the change equals the final energy. What kind of initial energy do we have? 3 types. So I could have kinetic energy to start with. I could have the potential energy due to gravity, and I could have the potential energy due to a spring. Those are my 3 types of initial energy that I could have. Same thing here. I could have kinetic at the end, I could have gravitational potential, or spring potential. Okay, and then there's going to be this plus or minus something, maybe. So in this case, just look at the initial point, nothing else, just this initial condition, and ask yourself 3 questions. Is it moving? Is an object moving? Nope, velocity 0. Well, that means there's no kinetic. Is an object above its lowest point? Well, it ends here, yeah. So we do have potential energy due to gravity. Is the spring extended or compressed? Well, there's no spring, so no. No. All right, that's the initial. In the final stage, is something moving? Yes. So they're moving at the end, which means they have kinetic energy. Are they above their lowest point? Well, no, they're at their lowest point. Nothing due to gravity. Nothing stored due to gravity. Okay, so that's our equation. The equation for this situation would be, we start with potential energy due to gravity. We end with kinetic energy. And we're not sure if there's going to be work. I'm going to say there's no work in this case. So actually, here, we'll do that. There's my energy conversion. We started with gravitational potential energy. It all got converted to kinetic energy. If I knew my mass, heights, velocities, that sort of thing, we could do the numbers. We're not going to worry about that right now. So that's just an example of an energy conversion. And you just have to say, okay, what kind of initial energy? In this case, gravitational. What kind of final energy? Kinetic. Second situation. Let's just toss a marker straight up. So I'm going to toss a marker straight up. So from leaving my hand, the moment it leaves my hand, to its maximum height, what kind of energy transformations are we seeing? So from leaving my hand to its maximum height. So what do we have? We have the marker, we're just using a box. So it starts just leaving my hand, going up, and then it ends up at its maximum height. What's the initial? What's the final? Well, the ones that make sense to me would have this be initial, this happens first, and then this is happening second. So what kind of initial energy do we have in this situation? There are three possibilities. We could have kinetic, potential due to gravity, potential spring. And we're going to be asking ourselves these same three questions a lot. Is something moving? Yes, it is moving. Just left my hand and it's moving upwards. So initial energy is going to be kinetic. And I'll put final energy over here. Is something above its lowest point? No. It's at its lowest point. So there's no gravitational. There's no spring. So initial energy, just kinetic. Final condition, we have these three. Is something moving at its final condition? No, because it's at its maximum height, not moving. So there's no kinetic. Is it above its lowest point? Definitely. So we have gravitational, no spring, we don't need to do that. So in this case, the energy transformation goes from kinetic to potential, just the opposite of what we had here. We started high with potential energy due to gravity, went down, which means that all that energy got converted to movement energy. Here we started with movement energy and it got converted to height, gravitational energy. Now let's do one more example with a skier again. Only this time I'm going to say it's not all that icy. There is some friction. So some friction, and I'm going to say that in this case, my two situations are that they start at some height with a certain velocity, and they're just going down slope at a constant velocity. So this is some velocity, it ends with some velocity. So it's moving down the slope at constant speed, the skier is. What kind of energy transformations do we have here? Okay, so initial here, I'm going to set my final to be here, and then let's figure out what my equation must be. All right, initial energy, three types. And again, if you want, this would be a good time to pause and see if you could figure out this equation on your own. What types of initial energy do we have? Is something moving? Yes. Initial energy, we have kinetic. Is something above its lowest point? Yes. We have gravitational. There's no spring at all. Don't have to worry about that. In the final situation, what kinds of energy do we have? Is something moving? Yep. We have kinetic energy. Is something above its lowest point? No, we're at our lowest point. No gravitation. And there's no spring. All right, so this would be the transformation that we've got. But if you look at this kinetic energy and this kinetic energy are going to be the same because they're moving at a constant speed. So if they're moving at a constant speed, they haven't changed their energy at all. Which means that this would be like, 14 plus 20 equals 14. You know that can't happen. Something has to happen in here. So in this case, this is an example where we would have work done. And we know it would have to be negative work because we have to subtract off some energy to get back to 14. So the work done would have to be a negative 20 of whatever it is. Now what would do work? What would take away energy from the skier as they're going down the slope? So stop and think about that for a second. What takes away energy as they're moving down the slope? And let me remind you that I said it was no longer very icy. If you guessed friction, you are right. So what we would have in this situation is we would have negative work done by friction. Friction between the skier and the slope is going to be taking energy away from what we're going to call the system of the skier. So that's an example of a situation where we would see a work term in our energy equation. So what unit does energy have? It's got the unit called a joule, and a joule is equal to a Newton times a meter. But unfortunately, we had this for torque, so instead of calling it a Newton meter, we call it a joule. So the unit is a joule. And just to give you a sense of how much a joule is, here are some examples, and this will be good for you to keep in your mind or keep in your notebook, so that when you get an answer and you say, okay, it's 60 joules, is that a reasonable answer? You'll have a sense. So a person walking, they have about 70 joules of kinetic energy. A fastball, baseball, fastball, is a bit faster. And a bullet, faster yet, that's about 5,000 joules. A car going 60 miles an hour, that's a lot, 500,000 joules. So a car going 60 miles an hour has a lot of energy. Now back in 2004, there was a tsunami in Indonesia. And in 4 minutes, the amount of energy that tsunami had was, this is crazy, 2.5 times 10 to the 18 joules. It was enough actually to power the US for quite a while, and that's 4 minutes. It had that much energy. So there are some examples of the size of a joule. You know, so a housefly buzzing around would be close to a joule, maybe a little bit less. And so keep these in mind when you're coming up with answers, because if you get an answer that's 50,000 or something and it's for a person walking, you'll say no. So that's my introduction to energy. It's one of the easiest units conceptually. People tend to get it pretty quickly. And just keep in mind this idea that you have a certain amount to start with, you have a certain amount to end with, and then you have things that change that amount. Same thing with energy. If you get that, you'll be in pretty good shape. Good job.